Hello Algebra 2, this is your Quarter 1 exam review. In problems 1 and 2 we will be evaluating expressions. So what we're going to do is we're going to take the number and we're going to substitute it for the x. So I have 3 times the square of negative 4 minus 4 times negative 4 minus 5. So using order of operations, we are going to first do the exponent. Negative 4 squared is positive 16. And then we can multiply. Negative 4 times negative 4 is a positive 16. And then minus 5. So using order of operations again, we're multiplying, and we have 48 plus 16 minus 5, which equals 59. If you want to do that on the calculator, you can type it as well. So you would have 3 parentheses negative 4, and then press this button here for squared, minus 4 parentheses negative 4, close parentheses, minus 5. And you also get 59. Problem 2 is the same idea. We're going to substitute the 3/2. So I have negative 2 times the square of 3/2 plus 6 times 3/2 minus 1. So when you square 3/2, you square the 3 and the 2. So I have negative 2 times 9 over 4. And everything else I'll bring down. And then I'll multiply. So I get negative 18 over 4, which simplifies to negative 9/2, plus this gives me 18/2. And since I'm going to need a common denominator, I'll change my 1 to be negative 2/2. So now I have a common denominator. I just need to do negative 9 plus 18 minus 2, and I get 7/2. Or if you were to do that on a calculator, it would tell you 3.5, and either answer is fine. Okay, moving on to absolute value equations. In absolute value equations, you need to get the absolute value all by itself before you write your two different equations. So to isolate the absolute value, I'm going to add 6 to both sides. And I have the absolute value of 2m plus 3 equals 11. Now you can write two equations. 2m plus 3 equals 11, or 2m plus 3 equals negative 11. So I will subtract 3 on both sides. 2m equals 8, and divide by 2. m equals 4. Or, over here when I subtract 3, I get 2m equals negative 14, and when I divide by 2, I get m equals negative 7. So there are two solutions. In problem 4, the absolute value is already isolated, so I just write two different equations. 9 minus 4z equals 51, or 9 minus 4z equals negative 51. So the 9 is positive. I'm going to subtract the 9, and I get negative 4z equals negative 42. And then divide by negative 4. And we're going to get z equals 10.5. Let's go back and look at this again. 51 minus 9, that's positive 42. So then when I divide, I get a negative. Over here, I'm going to subtract the 9, and this time I'll get negative 60. And still that equals negative 4z. And when I divide by negative this time, I'm going to get positive 15. So z equals negative 10.5, or positive 15. Now we're going to solve inequalities. If my inequality starts as a less than, then that's going to be an and. and if it starts with a great or, that's going to be an or. So here's my less than. I have 3 minus x is less than 7, and 3 minus x is greater than negative 7. Subtract 3 from both sides, and negative 7 is less than 4, and then divide by negative 1, and I get x is, when you divide by a negative on both sides, you need to flip your inequality, so I get x is greater than negative 4. And subtracting 3 on both sides, negative x is greater than negative 10, divide by negative 1, and that means I need to flip my inequality, so x is less than 10. So x is both greater than negative 4 and is less than 10, so I need both of those numbers on this number line. I need negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Okay, so it's greater than negative 4. It doesn't equal negative 4, so you do an empty dot to say leave out negative 4. And it goes all the way up to 10, but not quite. It's less than 10. So another empty dot at 10 to show that part of the solution. And then if we want to show that in interval notation, parentheses means not including negative 4, and up to 10 with parentheses as well. Okay, next one. We need to isolate the absolute value before we write the two equations, or the two inequalities. So subtract the 2 to start. 3 times the absolute value of 2x plus 6 is greater than 6. And now divide both sides by 3. So now the absolute value is isolated. Absolute value of 2x plus 6 is greater than 2. And that's going to be one of the inequalities. 2x plus 6 is greater than 2. And the other one is 2x plus 6 is less than negative 2. So now we're going to subtract 6 from both sides. 2x is greater than negative 4. Divide by 2. And x is greater than negative 2. Or, on this one, we get 2x is less than negative 8. And we divide by 2. X is less than negative 4. So let's see how that would look on the number line. Oops, there's a number line down here. Did not realize that. Okay, so I need a negative 4 and a negative 2. So let's call this one negative 4, which makes this one negative 2, and this one 0. So it is either greater than, or equal to. Now that I look back to the original problem, I see they all had equal to on them. So it's either greater than or equal to negative 2, or it's less than or equal to negative 4. So in interval notation, over here, this is negative infinity up to negative 4. We want to include negative 4, so that's the square bracket. And then we have starting at negative 2 and going to infinity. In 7 and 8, determine whether each relation is a function and justify your answer. So what we're doing is we're looking at the set of inputs, 1, 3, 5, 1, 6. If an input is repeated, you need to check and see, does it have the same output? So the 1 has an output of 4, and over here it has an output of negative 8. So if 1 has two different outputs, 4 and negative 8, then this relation is not a function. In problem 8, we're checking the inputs, negative 5, 0, negative 2, positive 5, and 7. None of these are repeated, So this is a function. All right, let's turn to page 2. What is the domain of the function if the range is -8, -2, and 10? Okay, so remember that the range is the y values. So they're telling us these are the y values. And remember f of x, that's the fancy way to say y. So they're telling us these are all 3 answers to 3x minus 2. So what we're going to do is we're going to set them equal to the y and solve for x, and we need to do that 3 times. So the first one is -8 equals 3x minus 2. Add 2 to both sides, and we get -6 equals 3x. Divide by 3, and x equals -2. The second one, let's see, -2. So -2 equals 3x minus 2. Add 2 to both sides. 0 equals 3x. So when you divide by 3, you get x equals 0. And then the third one is 10. 10 equals 3x minus 2. Add 2 to both sides. 12 equals 3x, and divide by 3. So x equals 4. So they're asking us the domain. The domain will be the set of x values. So draw your fancy brackets. And usually your teachers like you to write these in numerical order, but it looks like they're already in numerical order. Smallest is -2, then 0, and then 4. All right, in 10 it says write an equation for the vertical line going through the point -6, 4. So let's think about where that point would be. -6, 4. It's back 6, 1, 2, 3, 4, 5, 6, and then it's up 4. So back 6 and up 4. And then the vertical line is the line going up and down. So it's going through the x-axis at -6. So this is x equals -6. In 11, m varies jointly with a and b. So that means m equals some constant k times a times b. Then we use this information to find k. So m equals 84. We're going to find k, so it's still a variable, times 8 and times 21. So 8 times 21 is 168. So 84 equals k times 168, and then divide. And we should get k equals 1/2. So then our equation is m equals 1/2 times a times b. Now what we're going to do is we are going to find a when m equals 121.5 and b equals 9. So m is 121.5, 1/2 times, we don't know a, and we know b is 9. So you do 9 times 1/2, and you get 121.5 equals a times 4.5. And then we divide both sides by 4.5. And we get a equals 27. In 12, z varies jointly with x and y. So z, let's try that again, is equal to a constant k times x times y. What is the constant of proportionality? So the constant of proportionality is the k. That's what we're trying to find. If the z is 21, when the x is 1/2 and the y is 3. So we have 21 equals k times 3/2. And you can divide by 3/2 on both sides, or you could multiply both sides by 2/3. So I would have 2/3 times 21 equals k times 3/2 times 2/3. So the 3's cancel and the 2's cancel, and you have k by itself. 21 divided by 3 is 7, times 2 is 14. So that's your constant of proportionality. If you want, you can do this on the calculator as well. So you could do 21 divided by, parentheses, we're dividing both sides by 3/2. By 3/2. And you should still get 14. Okay, problem 13 is a quadratic equation in vertex form. So remember, vertex form is a times x minus h squared plus k. So because of the minus in the formula, the h is actually the opposite of this number. And then the k is the same as this number. So your vertex, hk, is -5, comma, -3. Okay, now we need to graph. So we're going to graph an inequality, and it's a greater than, and it's not equal to. So that means we're going to have a dashed line. If I want to graph this with mx plus b, the b is my y-intercept. So on the y-axis, I start at 4. 1, 2, 3, 4. My slope is -1. You can see that there's a negative there, and I can put the 1 in. So my slope is -1, and to make it a fraction, it's -1 over 1. So that means your rise is -1, and your run is 1. So down 1 over 1, down 1 over 1. And this is going to be a dashed line. You can continue the pattern backwards as well. Okay, so you can see the dashed line. And it says y is greater than this line. So y is the value, these y values are more than this line. So for that reason, you're going to shade above the line. And any point in this shaded area is a solution to your inequality. In 15, we're graphing a line, and this time it's an equation, so we're not going to shade. And we can graph this using intercepts. So to find your x-intercept, you make the y 0. So to find your x-intercept, you put 0 for y, so you have -2x plus 6 times 0 equals 12. Well, 6 times 0 is 0, so I'm going to get rid of that. And now I'm going to divide both sides by -2. So I get x equals -6. So on the x-axis, I want to mark -6. 1, 2, 3, 4, 5, 6. To find your y-intercept, you want to make the x 0. So -2 times 0 plus 6y equals 12. -2 times 0 is 0, so that's gone. 6y equals 12, divide both sides by 6, and we get y equals 2. So our line is going to go through those 2 points. Okay, and so your x-intercept is at -6, 0, and your y-intercept is at 0, 2. So that's the end of page 2, and there's a new video for pages 3 and 4.